So I think we'll go ahead and in the interest of time, we'll move on to Dan Moriarty's presentation. Dan, are you on?
Yes, do you have my audio?
Yes. All right. We can hear you, so it's all yours. Thanks.
All right, thank you. So today we'll be talking about an early stage instrument concept designed to enrich and diversify the samples returned by the Artemis program. So the core instrument team is here at Goddard, but it also includes members at JSC, JAXA, UCF, PSI, and UC Berkeley. So I wanted to make sure to thank all of my co-authors on this study. Next slide, please. So as currently envisioned, the Artemis program encompasses sustained human and robotic activity around the lunar South Pole, with a regular cadence of landings and launches, as well as support from orbital assets. Assets at the Artemis site and in orbit are subject to a variety of small impactors. So two important types of these impactors are micrometeorites and also regolith particles that can be accelerated by rocket exhaust during spacecraft landings and launches. So although both of these impactor classes pose a potential hazard to human and robotic activity, they are also of high scientific interest. The basic principles of these processes are understood through numerical modeling and laboratory experiments. However, these analyses are only loosely constrained by lunar surface observations. So this really limits our ability to understand and mitigate the hazards posed. Furthermore, the Artemis architecture is unprecedented in terms of its duration, complexity, and also the polar environment. So the actual impactor environment that is experienced may be significantly different from kind of what we're predicting. Next slide, please. So the Aerogel experiment gathering impactor samples, or AEGIS, is an instrument concept that would greatly improve our understanding of the flux and other properties of micrometeorites and exhaust plume particles. So the AEGIS concept employs aerogel panels at the lunar surface and potentially in orbit, which are going to be optimized to capture both micrometeorites and exhaust plume particles. So surface deployed AEGIS panes would be collected by Artemis astronauts for return to Earth, which allows detailed analysis of things like the particle flux, particle composition, size, trajectory, and other properties. Installation of replacement aerogel panels for collection during subsequent missions would enable assessment of the evolution of the region through time. Next slide. AEGIS addresses several high priority science and exploration goals, which will feed back into the implementation of the aerogel collectors. So I've summarized 4 of the overarching themes here. So AEGIS will address the flux and composition of micrometeorites impacting the lunar surface to better understand the reservoir of these impactors. So this can help constrain models of near-Earth object origin and depletion. The instrument may also capture early solar system materials and interstellar particles, and this is relevant to critical cosmochemistry questions. Micrometeorite compositions may also shed light on the current rate of volatile delivery to the lunar surface. AEGIS will also help determine the energies and trajectories of micrometeorites to better understand their role in space weathering and also hazards posed to human and robotic lunar surface activity. In addition to micrometeorites, AEGIS will also record the flux, trajectories, energies, compositions, and other physical properties of blast zone particles to better understand the energy coupling between lander exhaust and the lunar surface, and then the hazard that those pose to lunar surface activity. Recent models by Phil Metzger suggest that significant volumes of regolith particles may also be accelerated beyond the lunar escape velocity by landers, and this potentially poses a risk to orbital assets. There's been some pushback in this model, but an orbital AEGIS deployment, perhaps on the gateway, could help constrain the magnitude of this process.
1 minute.
And through repeated surface deployments, AEGIS can also help understand the evolution of the blast zone particle load through repeated landings of variable spacecraft sizes, engine configurations, and locations. Next slide. So as of today, AEGIS is still an early stage concept. The instrument team is currently exploring funding sources to further mature the concept. And some specific parameters under development include aerogel composition. So numerous aerogel compositions and densities are available, optimized for different particle sizes, densities, and velocities. So it may be beneficial to leverage several compositions. We're also looking at ways to mitigate the flux differences between micrometeorites and exhaust plume particles. And we're also looking at how to optimize interaction, astronaut interaction. And so the next slide is just a summary, and I'll close there. Thank you very much.
All righty, thank you.